Codecs are the way that we actually take messages we really want to send electronically and then turn them into binary digits. This is where we're going to use Claude Shannon's information theory. This has proven to be the economic way of increasing channel capacity. It's a bit like using the short message phrases you may be used to using, like LOL for laughing out loud, or the letters G and R followed by the number 8 for great. Did you know that amateur radio operators have been using short forms for well over 100 years? They have a set of what are called Q codes, which stand for relatively long phrases that are commonly sent. For instance, QTH with a question mark means, where is your radio station located? QTH used alone means my radio station is located, and then you would give a geographical location. These are very commonly used to shorten messages down. In those days, the way most radio stations and television stations received their news was through the teleprinter. The news was transmitted using a codec called RTTY, radio teletype. Now, along comes Texas Instruments. Have you ever seen this device? It's a Texas Instruments Speak and Spell. It was meant for children. What it did was, it taught children letter sounds and words and the way we make up words with those letters. The genius of it was that it used a chip to digitize sound. The kind of chip was the first available, and it was available in this toy. But it's available in a lot of the devices you use today. It's available in your iPad and laptops of all brands. It's available in your cell phone. It's available on your iPhone, your Android phone. It's also used for commercial communications, as well as amateur radio operators using it messaging back and forth. It's an A to D converter. What does it do? Well, my voice is analog. The A to D converter allows my voice to be digitized. It does analog to digital conversion, and then at some point it may also reverse the process to a digital to analog conversion. Once digitized, a voice that is sent as digits can later be reproduced as a sound that the human ear can understand by simply reversing the process. A sound chip, like we've described, is probably the beginning and the ending of most of the telephone calls that you make today. Your voice is digitized. That digitized voice is sent wirelessly, first probably to a cell tower, and then through a set of wires, perhaps over microwave, again electromagnetic, and then it reaches somebody else's handset and is going through a digital to analog converter. Codecs are code-decode combinations. Amateur radio operators use codecs all the time. One of the codecs is Morse code. What happens here is we send short dits or dots and long das or dashes with spaces in between them, and those make up the letters. Longer spaces indicate it's the end of the word and the beginning of another word. You could send virtually anything you want back and forth by using digital Morse code. Packet, like those used for wired internet communications, is also a binary codec. It also has been used by amateur radio operators for years. One of the interesting uses of packet encoded wireless has been the Mars rovers, the ones that have been on the planet Mars for years. They're controlled by a packet wireless codec. How do you get a message to the rover that says, I want you to turn your front wheels 5 degrees to the right, and then I want you to engage your motor? There are no wires between Earth and Mars, so it's got to be wireless. It takes a very long time for the signal to get there, even though electromagnetic waves travel at the speed of light. The people at the Jet Propulsion Laboratory, JPL, who built the Mars rovers, decided to use radio that was the same kind of digital packet codec used by amateur radio operators. The people working in the Jet Propulsion Laboratory were amateur radio operators, and they decided to use something that, while it was an old codec and while it was slow, they knew how flawlessly it operated. They knew all of the problems you could have with that particular codec, and they knew how to solve those problems. In other words, it was old, but it was tried and true. Obviously, it's still working because the JPL crew is still driving the Mars rovers around. We can pack a large number of digital signals into a very small slice of the frequency spectrum. In other words, we can economize on spectrum, use it more economically.